This is 21.4 temperature. Introduction. Temperature is a huge part to the body and the performance of an athlete. An event that takes place in extreme heats is the Des Arbles Marathon, which is in 40-degree heats. An example of where hot temperatures has affected sport would be the Rio World Cup in football in 2014. In this, they had to play most of the games in the evening and the night times, as it was too hot in the daytimes. Despite this, they still had to have water breaks halfway through each half, due to it still being very hot and most of the players not being used to the climates. However, there are also events that take place in cold climates. For example, linking with the Des Arbles Marathon, there is also a marathon that takes place in cold temperatures in the North Pole. This is where athletes from all over the world run in minus 30 degrees, and they would have to train differently beforehand so that they could get used to the climate changes, as they were not able to take part in the event if they didn't. An effect on sport from cold weather would be for outdoor events like football, as they are often cancelled in the winter due to a waterlogged pitch from rain or due to there being too much snow on the pitch, so players are not able to play. Now I'm going to talk about the cold. When we get cold, there is one effect that happens, and this is hypothermia. And there are 3 different types of hypothermia: acute or immersion, exhaustion, and chronic. During acute hypothermia, you shiver due to your muscles contracting and releasing energy to warm up the body. Also, your breathing rate slows down and the participant can feel exhaustion and confusion, which leads into their speech being slurred or mumbled. During exhaustion hypothermia, the participant tends to have a weak pulse and slow breathing rate. Their speech is also slurred while feeling clumsy and drowsy. The participants can also have a loss of consciousness, and their skin tends to go bright red in the face. With chronic hypothermia, the same happens to the body as the other two, the only change being that it happens slowly over time instead of as soon as the participant gets cold. When an athlete is performing in a sport and they get cold, this can affect their performance massively. One effect being when a muscle is cold, this then increases the chances of the muscle tearing, and this can lead to injury. Despite this, there are also effects that can affect the athlete's performance there and then, such as them fatiguing and not being able to put in as much effort for as long as they normally would be able to. It can also mean that they get a poor coordination and disorientation, and that there is also a chance of a cardiac arrest, but is unlikely. When the body gets cold, the hypothalamic thermostat acknowledges the decrease in temperature. When this occurs, the peripheral thermoreceptors sends a message to the cerebral cortex in the medulla oblongata. The body then either has a voluntary or involuntary response. If the body has a voluntary response, this consists of putting more clothes on or rubbing their skin. But with an involuntary response, the body's response that occurs are pillar reactions where the hair on the arms rise to trap the heat. Now I'm going to talk about heat. In the heat, the body goes through different effects depending on the heat. At 38 Celsius, the body starts to sweat. At 39 Celsius, sweating increases and heart rate increases. At 40 Celsius, enzymes start to denature and dehydration starts to kick in. At 41 Celsius, fainting can occur as well as vomiting and dizziness. When the body reaches 42 Celsius, you start to vomit and become delirious. And when the body comes to 43 Celsius, you start to have brain damage and cardiorespiratory collapses, and finally when you reach 44C you risk death. To stop yourself from getting too hot, thermoregulation works to try and keep the body at a correct temperature. Some of these ways are in hairs laid down to trap less heat, vasodilation of blood capillaries, increase in sweating and a decrease in metabolic rate. All of this is controlled by the hypothalamus in the brain. These are involuntary responses, however there are also voluntary responses which consist of taking an item of clothing off or having a drink. Hypothermia is elevated body temperature due to failed thermoregulation that occurs when a body produces or absorbs more heat than it dissipates. Extreme temperature elevation then becomes a medical emergency requiring immediate treatment to prevent disability or death. This is a 6-day, 251 kilometers ultramarathon, which is approximately the distance of 6 regular marathons. The longest single stage is 91 kilometers. This multi-day race is held every year in southern Morocco in the Sahara Desert. It has been called the toughest foot race on earth. While the race is happening, over 120,000 litres are consumed by all the participants. Our method to see the difference in heart rate at different temperatures. The protocol. We did 10 minutes pre-cooling, then 10 minutes exercise in the chamber. We measured at rest heart rate, RPE, TSS, ear and forehead. Then the end of pre-cooling, we measured the same again. Then after exercise, we measured the same again. Rotation. The observer, who must stay outside of the chamber, the participant, the data collection, the power management, cycling, cadence of 70 RPM, pan weight of 1 kg, increase resistance by 0.1 kg each stage, and we rotated in these. Here are our results from the test. Here we can see when there was no pre-cooling, the participant's heart rate was above 160 beats per minute. Then when they got in the ice bath, their heart rate was just below 120 beats per minute. And when in the ice vest, their heart rate was just above 120 beats per minute. From this we can see when the body's temperature gets lower, the heart rate decreases. Here we can see the difference in two tables of pre-cooling with an ice bath and pre-cooling with an ice vest versus no pre-cooling exercise heart rate heat in two different tables. Here we can see that the mean difference in pre-cooling with an ice bath was more than 7 higher than pre-cooling with an ice vest. This shows us that on average the participants' heart rates were going higher after the ice bath than the ice vest. This could have been because the ice vest, the cold focused on the body where the heart is, so then the heart rate would have slowed down as it would have been colder. We then did a t-test for both of them to find out the p-values, and as you can see here, the p-value of the ice bath is 0.008 and the p-value of the ice vest is 0.000. So here we can see that they are both below 0.05, so then they are both to be significantly different.